Hello, I welcome you all in this video. Today's topic is called metals, a chemistry O-level topic. So we can see from the picture here that we have different types of metals, and these metals are into different shapes. Okay, so we have different types of metals. Metals are a very good resources to have. Okay, they are used for a number of things. So we have the general properties of metals. We can say metals are good conductors of heat and electricity. Okay, so good conductors of heat, this means that these metals, you can easily use them in places where you need heat conduction. And for example, you can talk about in the kitchen. Okay, so in the kitchen you have a lot of kitchen utensils that are made up of these metals. Okay, pans, frying pans. You also have pots. Okay, most of those are made out of aluminium. Okay, which is a very good method in using or making kitchen utensils, because it does not easily rust. Okay, then electricity, of metals like copper that are used for electricity. Okay, so you can see the metal here, copper. It can be drawn into wires. Okay, we'll look at that. So metals are malleable. It means that you can hammer them, and once you hammer them, they can become thin sheets. Okay, and we use them for our iron sheets. Okay, when building a house, you need to cover the roof. Okay, so iron sheets for our roofing. Also, metals are ductile. They can be drawn in two long wires. Like I've said, copper is used as most of the times into electric cables. Okay, so they can be drawn into long wires. You can see this is a metal that has been made into this type of a shape. Okay, metals are sonorous. That simply means they produce sound. Okay, when you hit them or hammer them with something. Metals are also lustrous, that is, they shine. So you can see how these metals are shining. Okay, a lot of them here are sparkling. Okay, metals are lustrous. They have silver luster surface when freshly cut. Then another important thing is that metals are solids at room temperature, except for one, mercury, which happens to be a liquid at room temperature and pressure. Another thing is that metals have got a high melting and boiling point. So now we are going to look at these, and we are going to see that some of these properties here. Okay, for example, high melting and high boiling point, we are going to discuss this under extraction of metals. Okay, and also you need to know these that I've highlighted in much deeper black or bold. Okay, just remember heat and electricity, they're malleable, they're ductile, sonorous, lustrous, and they're solids at room temperature. That will give you a good start when you are trying to discuss these metals. Okay, so these are the general properties of the metals. Now we're going to look at different types of metals, and then we see how these metals behave. Okay, so this is just the general property that applies to all metals, but we can look at each metal separately and just see how it behaves. Okay, and how wonderful that is. So we're going to now go into what we call the reactivity series. We see how these metals actually react when they are reacted with other things. So let's look at the reactivity series, which is also called as the activity series. So it is a list of metals, okay, with the most reactive metal at the top and the least reactive metal at the bottom. So as you can see here, we have these metals. Okay, starting with the ones that are very reactive with the ones that are less reactive. So now, how did they come up with this reactivity series? So the order of this reactivity was determined when a metal is reacted with either steam. Okay, if it's reacted with water, it's reacted with steam, and how it reacted with an acid. Okay, and in both types of reaction, you notice that there was hydrogen gas that was always what produced. So whenever a metal reacts either with an acid, it reacts either with steam or an acid. That reaction will show, first of all, it will show how reactive that metal is. Okay, The first thing, it's going to show how reactive that metal is. It will tell you how reactive that metal is, and we are going to look at how these metals react. So how reactive the metal is, and also it's going to produce hydrogen gas. Okay, it's going to produce hydrogen gas. So this is what we must always bear in mind. Okay, in the reactivity series we have a list of metals. Okay, and how did this list come about? They reacted the metals with water, steam, or an acid. Okay, and that showed how these metals actually reacted. And the most reactive metal here, you can see, starting with helium, but for the sake of our O-level exams, we usually start at potassium up to even platinum. Okay, even so, you know that lithium is so as you go down group 1 alkali metals, you see that there are other metals that are actually more reactive than potassium. Just to make our things easy for the sake of our exams, we will start from potassium up to platinum. Okay, so you can see from here that potassium is actually, these are more reactive, and the reactivity starts to reduce as you go down. Okay, so find that from all these metals here, it was discovered that they react with oxygen. Okay, that is when it comes to burning. Okay, so they'll show a reaction when you burn them with oxygen. And then metals that are, so you can see we have other things that actually are not metal that have been added in this group. There's carbon and hydrogen. These are not metals, but they are there for a specific reason, and here we're going to start with why hydrogen is placed. So hydrogen is placed here. First of all is that these metals, after reaction, they will release hydrogen gas. But again, hydrogen is also placed there because it differentiates the metals that can react with dilute acid. So you can see from top to bottom here, all the metals above hydrogen, they are able to react with dilute acids. Okay, so it distinguishes the metals that can react with dilute acids and the metals that do not react with dilute acids. So copper, mercury, silver, and gold, as well as platinum, these do not react with dilute acids. Okay, they do not react with dilute acids. That's why hydrogen is placed here. And then you also have metals now that can react with the water. These metals that can react with water, there are very few. Okay, so starting from here, you have these metals, you're able to react with water up to aluminium. Okay, we just put it up to aluminium, they can react with water. And then now carbon separates the metals that can react with water and the metals that do not react with water. Okay, so now there's this group of metals here, they are not put here in the line. So from zinc up to lead, these, since they do not react with, okay, so I'm going to put it here. So from zinc up to lead, these do not react with water. They will react though with steam. Okay, they will react with steam. We're saying they do not react with water, but they will definitely react with steam. So steam is just water in gaseous form. Okay, they will react with steam. Okay, so I know I've said quite a lot of things, and for you to really know these things, you need to spend a lot of time just trying to understand these things. Okay, so in the reaction, you have metals that will burn all the way up to silver, gold, and platinum. They do not burn in oxygen. These metals are very unreactive. Okay, but with dilute acids, all these metals above react with dilute acids. Yeah, the ones that react with water, it's from here up to aluminium. After carbon, going down up to lead here, these will react with steam. Okay, now the method of extraction also depends on the reactivity series. For example, the metals all the way up to aluminium here, you can extract them from the earth's crust using the process called electrolysis. Okay, and then after carbon, going down, those metals you extract them through reduction. We'll come to that. And these, you find that they are usually found in pure state underground. There's no need, so we're going to come to that. Okay, so don't want to say a lot of things. So the reactivity series is just a list of metals starting with the most reactive metal at the top, and so you can see how the reactivity just generally decreases. Okay, so now we move further. Alright, so there are a lot of mnemonics out there that are used to memorize the reactivity series. This always works out magic. Okay, so for example, I have this word here, po. Let me just edit it. I've forgotten one thing there. Okay, so you can see po, so, ka, mau, zi, fe, ti, h, commerce, gopt. Okay, so this just something I've been using for a long time, but there are a number of ways you could memorize these. Okay, so poso kama zife ti, h, commerce, gopt tries by all means to help you memorize these things. So this is potassium. Okay, sorry about that. Okay, so this is potassium, sodium, calcium, M, that is magnesium, aluminium, zinc, that's iron, that's tin, lead. So you can see here we are here. Okay, and then you have hydrogen, copper, mercury, silver, gold, and then you have platinum. Okay, so you have, after hydrogen here, you have copper, mercury, silver, gold, and platinum. Okay, this will give you at least a bit of an idea in order for you to understand these things. Okay, so there are some metals here. For example, nickel is not on this, and you don't have to worry about that. Okay, tin is there. Okay, lead. Okay, most of them, they are in this mnemonic. All right. Okay, so let's see how these metals actually react. Okay, it won't take much time. So potassium, you see, it can react with cold water, and the reaction is quite violent. Okay, but it will produce potassium hydroxide and hydrogen gas. Like I said, in all the reactions, you are going to notice hydrogen gas is given out. So potassium hydroxide, this is an alkali. Okay, very strong alkali, a base. Okay, so you have potassium reacting with cold water here to give us potassium hydroxide and water. So the same thing happens with sodium. The reaction is very violent as well. Okay, it's violent with cold water, but it will produce sodium hydroxide. So you notice each time you're going to have this hydroxide produced. So same thing with calcium, but the reaction tends to be less violent. Okay, with cold water, you have calcium hydroxide and hydrogen. You notice again magnesium here, the reaction becomes a bit slow, so it will give us magnesium hydroxide and hydrogen. Okay, sometimes it will give magnesium oxide. So aluminium, this one now is where you see the reaction now stops reacting with cold water, hence we use steam to see the reactivity of the metals going down. So all these zinc, iron, you notice they will react with steam, like I've already explained, okay, previously there. So until you have a poso kama zife H comescopt, okay, poso kama zife T, so you have lead here. Okay, going down, these do not react with the cold water, they do not even react with steam, but we have two of them at least that will react with an acid, and we're going to look at that. So reactivity of metals with an acid now. So if you get potassium reacting with a dilute acid, the reaction is explosive. Okay, this is very dangerous. It will react so much that it will cause an explosion. Okay, so these are giving out salts. Okay, they give out potassium chloride, sodium chloride, these are salts. So all the metals all the way up to lead, they will react with acids, okay, to give salts and hydrogen. You notice copper and gold do not react with acids, even if that acid is concentrated. So reaction of metals with oxygen, you have a good number of metals will react with oxygen, all the way up to copper. Okay, gold does not react. Okay, even platinum as well will not react. Okay, so just take a minute to understand these things. Okay, you don't need to know each and every equation, you just need to have at least an understanding how these metals will definitely do what will react. So let's do a simple activity. Iron, calcium, copper metals below describe the reactions of these. Okay, so place a tick. Let's do this. Okay, so we have the reaction of a metal with cold water. We know definitely that copper does not react with cold water. Does it react with steam? No, it does not. Iron, does it react with cold water? Yes and no, it does not. Reaction with steam, yes it does. Calcium will react with both cold water and steam. Okay, so this is that. Okay, I'm sure you have a better understanding now. Okay, you can try and pause the video, try to see if you can work out this exercise. Okay, we just move further, and we're going to what we call displacement of metals. Okay, so a metal that is high in its reactivity series will displace a metal that is less reactive. Okay, so we're going to explain this. Okay, so displacement of metals. Okay, we're saying that a metal that is high in reactivity series will displace. Okay, it's going to displace a metal that is less reactive. Okay, so we're going to have examples here. So what we are saying is, if you get iron and you react with copper 2 sulfate here, this iron will displace the copper in this, so it's going to be here. So you're going to have copper, you're going to have iron, okay, iron 2 sulfate forming. That's what the displacement. So since iron is more reactive than the copper, so it displaces it. So the reaction you can see here, iron plus copper 2 sulfate, what happens, this iron comes here and then the copper is displaced here. So you see it forms the iron. Now remember, these metals, some of them, they have a color that you can notice. For example, copper 2 sulfate here, it's blue. Okay, it's blue, but to show that it's been displaced, iron carries another color, which is what? Green. Okay, so you can easily observe, if you're in the lab, you can easily observe this. You have a test tube there. When that is just starting, the copper 2 sulfate solution is blue. Now immediately you just add in the iron. Okay, immediately you add in iron, it changes the color to green. That will tell you that iron has displaced copper in this reaction. Okay, so between copper and Ag is silver. I'm sure we know that. Between copper and silver, so copper can replace this. Okay, copper is more reactive. Okay, so it will definitely displace this. Okay, so you have copper displacing silver. Okay, now in this reaction, you have iron, zinc sulfate. Zinc is more reactive than iron, so this won't be able to take place. Okay, this reaction won't take place because iron is not able to displace zinc. Okay, so always remember this: a higher metal in the reactivity series will always displace a less reactive metal. Okay, so that is what we are saying here. Let's try to do this. What would you see when zinc is added to copper 2 sulfate solution? Now zinc is more reactive than copper, so what will happen? Zinc will displace the copper and form zinc 2 sulfate. Okay, or zinc sulfate. Will copper react with zinc sulfate? No, because copper is less reactive than zinc. Okay, so that is how you do this thing. So now these metals are all over and everywhere. We have to have a way of recycling the metal because we extract these metals from underground, and that's what we are going to look at in our next videos. Right, so before we end the video, make sure you try as much as possible to memorize this. You can make your own mnemonic if you wish to. Okay, but what we are saying is that just knowing these will help you very much, especially when doing the displacement reactions, to know which metal is more reactive than the other. Once that sticks in your head, you'll be able to answer these questions without any sweat. Okay, so that's all in this video. Okay, so for those that would like to maybe join us, we offer online tuitions. Okay, you might as well just WhatsApp. Okay, you can WhatsApp us in this number. Okay, and our country code is plus 2026. Okay, see you.